is lesson 10.8, compare linear, exponential, and quadratic models. You should be on page 684. So far, you've studied linear functions, exponential functions, and quadratic functions. Now, we studied linear functions in first semester. That was chapters 4 and 5. We studied exponential functions in chapter 8. That was an example of the woman who put away 160 in stocks and it exploded to 7 million by the time she passed away. And then the last two chapters, chapters 9 and 10, were over quadratic functions. Now, here's a good review of linear, exponential, and quadratic functions. Linear functions have the equation form y equals mx plus b. Linear means, you can see it in the word, linear is line. Linear functions create a straight line graph. M is the slope, b is the y-intercept. An exponential function has the form y equals a times b to the x power. A, in this case, is the y-intercept. So a little review of that. And then b is what we're multiplying by to make this thing either explode up in value or we could have exponential decay. Remember, if b is a value, let me write this down, if b is bigger than 1, we have growth, and if b is between 0 and 1, then that would be an example of decay. And then, of course, in chapter 9 and 10, we worked with quadratics and how to solve those, and we sketched those. You can see here the basic form is called standard form. Now, one thing they will have you do in the homework is they will have you graph your function and then determine, is it linear, exponential, or quadratic? So I'm not going to spend a lot of time with this. Like, in example A, they took those points, they plotted them, you can see that right here, and can you tell that that's an exponential graph? It starts low and it explodes upward. Starts near 0, I should say it starts near 0 and explodes upward. Or in part B, they took these points and they plotted them on graph paper and it created a straight line graph. That's linear. Or in part C, they had you take these points and they had you graph them and it's creating a parabola. That's a quadratic. So I don't know that I need to spend a lot more time on that. One of the things in the homework today will be take graph paper and they will ask you to graph these points and then determine by looking at your graph what type of function it is. Is it linear, exponential, or quadratic? Now, another thing we're going to have to do is we need to be able to look at a table and determine, is it linear, exponential, or quadratic? Now, two of these we've already learned, linear and exponential, but we'll review those now. Differences in ratios. A table of values represents a linear function if the differences of successive y values are all equal. Another way of saying that is if you look at the y values, let me highlight them. If you look at the y values and you see a constant addition or subtraction pattern, that means it's linear. Now, one thing we have to be careful of, and there's a little highlighted note, maybe I'll circle this or box it in red. This is important. When I say if there's a constant addition or subtraction pattern, you got to check real quick, are the values for x increasing one at a time or at the same interval? Because if they're not, then what I just told you might not necessarily be true. So you notice here, x is going up 1 each time, so we have a constant increase for x, and y is going up 3 every time. So since there's a addition or subtraction pattern for y in this case, it's definitely linear. Now let's review how we write the equation. Here's the slope. We're going up 3. You can see that here. We're rising 3, and we're running 1. There's your slope, 3 over 1, which is 3. That's why you can see m is 3. I'm underlining it here. and right there's your y-intercept. Your y-intercept is 5, so they put a 5 in for b. It should be really easy to write an equation in slope-intercept form if you have a linear table. Next, exponential. A table of values represents an exponential function if the ratios of successive y values are all equal. So here's another way of saying that. They're saying, is there a multiplication pattern? Now again, what I put here holds true. You got to check the values for x. Do we have a constant rate of increase here? And yes, I do. I have 1, 1, and 1. So do you notice we have a multiplication pattern? 0.25 times 2 gives me 0.5, and 0.5 times 2 gives me 1, and 1 times 2 is 2. This is definitely an exponential function. So the function is y equals a times b to the x power. Since I'm multiplying by 2 each time, b is 2, and here's my y-intercept right there, 0, 0.5, so my y-intercept is 0.5, and there's my function. Y equals 0.5 times 2 to the x power. It's kind of nice that we have this lesson right now. This is reviewing part of, this was chapter 8, and since final exams are coming up, here's a good review of a portion of chapter 8, how to write a rule for an exponential function. Now the newest function we have, of course, is a quadratic. You can use differences. Remember, difference means subtraction. You can use subtraction to tell whether a table of values represents a quadratic. The table of values represents a quadratic if the second differences are all equal. So here's what they mean by second difference. They highlighted it here in the book, and let me get some colored markers to color code this. Okay. They have this term, the first differences. If you have a quadratic, your second differences would all be the same. Now, to get the second difference, you got to calculate the first difference. Here's what they mean by first difference, the first subtraction. Let's do a subtraction. We're taking 2 minus 5, and that gets us negative 3. And then we're taking 1 minus 2, and that gives us negative 1. And then we're taking 2 minus 1, which is 1, and then 5 minus 2, which is 3. Now, that's called the first difference. Okay? Now, if my second differences are all the same, that would make this a quadratic. Let's check. Negative 1 minus negative 3 would get me positive 2. Positive 1 minus the negative 1 gets me positive 2. And 3 minus the 1 gets me positive 2. Do you see how the second differences are all the same? They were all 2. That means I have a quadratic. Now, if I give you a question from scratch, I normally check, is there a linear pattern first? Let's go back to this problem and check. Is there a constant addition or subtraction problem? Or constant addition or subtraction pattern? Well, let me see. 5 minus 2 is 3. 2 minus 1 is 1. Okay, this can't be linear. I don't have a constant addition or subtraction pattern. Okay? Let's see if it's exponential. Is there a multiplication pattern? Well, I know 2 times a half would give me 1. Does 1 times a half get me to 2? And no, it doesn't. So I know right now this table can't be linear and it can't be exponential. So now I check on the second difference as I just showed you. Now, there's only one way we can really get the equation for a quadratic. We have to, and here it is, make a table on your calculator and then do a quadratic regression. So let's do that. Let's get out our calculator. And now we have to type in the table. So hit stat, option 1, and there's our table. Let's type it in. And as you can see here, I did type in my table. And now, if you haven't typed in your table, make sure you do so. And now after you have the table typed in, you're going to do what's called a quadratic regression. Go back to the stat key, go to calc, and find quadratic regression. It looks like option 5 is quadratic regression. So what you're telling the calculator is, I know my table is going to give me a quadratic. Calculator, would you please get the equation for me? Press enter. Now, depending on what version of the calculator you have, you might have to scroll down to calculate. I just have to press enter again. And you notice I'm getting the same thing that you see in the book. The answer I'm getting is that I have y equals 1x squared minus 2x plus 2. That's what the A, B, and C are telling me. A is 1, B is negative 2, C is 3, and I'm just writing that here. And this is matching the book. And you can see that right here. It's matched in the book. So let's practice a couple of these. Use differences or ratios to tell whether the table of values represents a linear function, an exponential function, or a quadratic. So this first table, let's look at it. And they give us the answer here, but let's pretend they didn't. Let's check. Is it linear? Is there a constant addition pattern? Well, first of all, I got to make sure, are my x's going up at the same interval? They are by 1 every time. Good. Now here, negative 6 plus 0 would give me negative 6. Is negative 6 plus 0 going to give me negative 4? And nope. So I know right now this one can't be linear. Let's try exponential. Negative 6 times 1 gives me negative 6. Is negative 6 times 1 going to get me negative 4? Nope. So this is definitely not exponential. So now I got to check, is it a quadratic? The only way I can tell is by checking, are the second differences the same? Well, let's get the first difference calculated. Negative 6 minus negative 6 is 0. Negative 4 minus negative 6 is 2. 0 minus negative 4 is 4, and 6 minus 0 is 6. That's called my first difference. I need to figure out, are the second differences the same? Well, let's check on the second differences. 2 minus 0 is 2. 4 minus 2 is 2, and 6 minus 4 is 2. The second differences are all the same. Okay, let's write an equation for this then. So we got to get this in our calculator. I'm going to pause the video and get this table in my calculator. Why don't you get it in your calculator too? And you can see I have my table typed in my calculator, so I'll go to Stat, Calc, Option 5 is a quadratic regression, and there's my equation. So the equation for this problem must be y equals x squared plus 3x minus 4. So it should be easy for you to calculate a quadratic by just putting the table in your calculator and doing a quadratic regression. Let's go to that next question, and let's do that one also. Let's check here. What type of table is this? Well, let's check on linear first. Double check, are the x's going up in a constant pattern? Yes, we're going up one at a time. I always want to check that first. Okay, now let's see. Negative 2 plus 3 is 1, and 1 plus 3 is 4, and 4 plus 3 is 7, and 7 plus 3 is 10. This is definitely a linear pattern. Okay, so first of all, we're rising 3 and running 1. We're going up 1 every time here, 3 here. So rise 3, run 1. My slope is 3, and I'll highlight my y-intercept. It's right there. My y-intercept, b, is 4, so my equation must be y equals 3x plus 4. Why don't you try the next couple here? Oops, I'm losing my spot. I want you to try these two real quick here. Sketch this, or make this graph, tell me what type of function you have, and then tell me what type of table this is. Pause the video and do that. The first question, this looks like it's half of a parabola. This one is definitely going to be a quadratic. So we have a quadratic for number 1. And in this question here, this is certainly not linear because 2 plus 5 is 10, but 0.4 plus 5 isn't 2. But if I take 0.08 times 5, I get 0.4, and if I take 0.4 times 5, I get 2, and if I take 2 times 5, I get 10. This is definitely exponential. So y would equal a times b to the x power. My b value is a 5, and my a value, you can see right here's my y-intercept, it's 2. There would be the equation for this particular table. This is called the rule for the table, all right? I think this next part I can skip over now. They talk about how we write an equation. Well, in my video, I've already showed you how to write an equation for all 3 forms, linear, exponential, or quadratic. So what they have here in the book, just disregard this. I already showed you how you can write an equation for a quadratic. You're going to have to put it in your calculator. Why don't you quickly try these 2? Pause the video and try to find if these are linear, exponential, or quadratic tables, and then write the rule. For the first question here, do you notice x's are always a constant addition of 1, so I always want to check that first. Now, the y's keep on going up, adding 2 every time. This is definitely a linear table. I should write that down. This is a linear table. Now, my slope is up 2 over 1, and my y-intercept is right here. I'm starring it. It's negative 1, so there's my slope 2. My y-intercept's negative 1, so there's my rule. Y equals 2x minus 1. For this next question, I know it's not linear because here's why. 8 minus 6 would give me 2, but 2 minus 6 doesn't give me 0. So I can scratch linear off the list. Let's try exponential. 8 times a quarter gives me 2. Does 2 times a quarter give me 0? Nope, so I know it's not exponential. So let's check, is it quadratic? Second differences. 2 minus 8 is negative 6. 0 minus 2 is negative 2. 2 minus 0 is 2, and 8 minus 2 is 6. That's called the first difference. I'll just write first here. Let's get the second difference, see if they're the same. Negative 2 minus negative 6 would be positive 4. 2 minus negative 2 is positive 4, and 6 minus 2 is 4. Yeah, my second differences are the same. Okay, let's get our rule real quick. I'm going to pause this and put it in my calculator. You can do the same. And you can see I've entered that table in. I'm going to hit Stat, Calc, Option 5, Enter. Okay, this is an easy one. This is just going to be y equals 2x squared. There's the rule for that. B and C were 0, so those kind of just disappear. There's my rule. You could have story problems involving figuring out, is this situation linear, exponential, quadratic? The table shows the breathing rates, y in liters of air per minute, which you see they labeled, of a cyclist traveling at different speeds in miles per hour. That's the x. So the speed is the x, the breathing rate's the y. Tell whether the data can be modeled by a linear function, an exponential function, or a quadratic, then write the equation. So the book says to go ahead and graph it, and if you graph these points on graph paper, you'll see a little curve to this. And if you see a little curve, you know right now it can't be linear. So if there's a little curve, you'd have to decide, is it exponential or quadratic? Well, they start going with the table, and this is where I think it is easy to talk about. They said it earlier that exponential functions have the same ratio. Well, if you check, here's what they mean by ratio. It's a multiplication pattern, but here's the ratio. 57.1 divided by 51.4 is about 1.11. 63.3 divided by 57.1 is about 1.11, and 70.3 divided by 63.3 is about 1.11. You notice every time I divide these, I'm getting the same ratio. So in other words, this is saying if I take 51.4 and multiply by 1.11, I get here. And if I take this number times 1.11, I get here. And if I take that times 1.11, I get here. We definitely have a multiplication pattern. The ratios are the same. This is definitely an exponential function. So y would equal a times b to the x power. I know b is 1.11. I got to find a, and they don't have 0 on here. So the easiest thing you can do is take an ordered pair like 20 and 51.4. Now think about that. X is 20. Y is 51.4. So this is x, this is y. Take 20 and plug it in for x. And take y, which is 51.4, and plug it in for y and solve for a. Once we have a, we'll have the equation. So you can see they're doing that in the book. All right? So if we take and solve this, to solve for a, all I have to do is divide each side by 1.11 to the 20th power, which you see here, and that calculation will tell me a. So if I take 51.4 divided by 1.11 to the 20th power, my a value is about 6.38. So my equation would be y equals, you can see it here, 6.38 for a times 1.11 to the x power. Okay, I'm going to pause the video there. If you have questions, make sure you ask in class.